Hello and welcome to Physics Like a Boss. Our problem this time is an airplane is traveling 999 kilometers per hour at a heading of 30 degrees west of north. Compute the displacement vector after flying 30 minutes. Express your answer in meters in component form. And we're going to be using the idea problem solving format, which I'll remind you of as we go.
With God's help, you can do physics like a boss, as you are created.
You are created in God's image.
To be fruitful and multiply.
Fill the earth and subdue.
Do it.
I'm kind of short, so sometimes I may disappear, but no worries, I'm here. I want you to be able to see the whole board. The first step in our physics problem solving format, the I, stands for interpret. Now, let's interpret this problem, and that usually involves drawing a picture. You don't have to be an artist, but you need to do something that's going to help you solve the problem. Often that requires setting up a coordinate system. So this, we will have x-axis be our horizontal axis and y on the vertical axis. Now, we're dealing with geographic location type terms, and so let's go ahead and call this vertical direction north, and that gives us east, south, and west to work with. And we're told that this airplane is traveling 30 degrees west of north. So this is 30 degrees here. Oh, that's terrible. Probably can't read that. Okay, this is 30 degrees. And we're also told that the speed is 999 kilometers per hour. Okay, so what general principles of physics are we working with? You want to identify that because we do not want to be playing formula roulette. We kind of want to know where we're going and what concepts we're going to be using in this problem. So the first one is just the definition of velocity, which is a description of motion with respect to time that includes both magnitude and direction. So we're going to be working with angles as well as numbers in this one. And then the way we do that is through the use of vector components, an essential skill, don't skip it, for the rest of your success in physics. Okay, the next step of our problem solving format is called develop. That means we're going to make a plan for what we're going to do. God has crowned you with glory and honor.
Honor to rule over his creation.
First, we want to convert all of our values into SI, or standard units. So that means converting kilometers to meters. And we need to convert time, which was given to us in hours, and make sure that it is expressed as seconds. If we had mass in this problem, we would want to have mass in the units of kilograms, but we don't. Okay, so then we need to compute the angle relative to the x-axis. We're given an angle that's relative to the y-axis. This is another way of kind of putting it in a standard notation. All right, so we've got those three steps. Anything else we need to do? Well, yeah, then we need to actually work the problem, right? So then we're going to compute the x and y components of velocity. And then we're going to compute the x and y components of displacement. I probably should put a comma there. Science is a gift from God
to help us master nature,
but sin added thorns and thistles,
requiring the sweat of your brow to succeed.
Okay, now that we've made our plan, let's actually evaluate, or the E step of the problem solving format. First of all, we're going to convert our units into standard units. So we start with the magnitude of our velocity vector, 999 kilometers per hour, times, we want hours in the numerator to cancel out. We need seconds, so we know an hour is 3,600 seconds. And then we'll go ahead and take care of kilometers also. We need kilometers in the denominator, and we know there's 1,000 meters in a kilometer. All right, so now let's check. We've got kilometers, canceling out kilometers, and we've got, I'm not trying to erase, it's supposed to be purple. Okay, we've got hours here. canceling out the hours, and we end up with an answer of 277.5 meters per second. We can work with that. Now, similarly, the angle is going to be expressed relative to the x-axis. And let's remind ourselves of our picture here. The angle was 30 degrees with respect to that y-axis. But we need it with respect to the x-axis, so we need to add this 90-degree angle. My purple pen doesn't want to work. We're going to add this 90-degree angle to the 30 degrees. And that's going to be 30 degrees plus 90 degrees, 120 degrees with respect to the x-axis. All right, now we're ready to compute our x and y components of velocity. The x component is going to be equal to the magnitude of the velocity vector times the cosine of the angle. And so that's going to be equal to 277.5 meters per second times the cosine of 120 degrees. And that is going to give us an x component of negative 138.75 meters per second. And let me take a moment to talk about the negative. Negative doesn't mean it's flying backwards, okay? Negative means with respect to how we've defined the coordinate axis, their positive and negative directions, and that's actually consistent with the airplane going, the x component being going in a westward direction. Okay, so now the y component, similarly, is the magnitude of the velocity vector times the sine of the angle this time. So it's still 277.5 meters per second this time times the sine of theta, and that is going to give us a y component of 240.32 meters per second. Learning physics
often requires prayer
as we submit
to Jesus Christ
as risen
King of Kings and Lord of Lords.
Okay, now that we have our x component of velocity and our y component of velocity, we can use those to compute the x component of the displacement, which is going to be the x component of velocity times the time, which we've computed as minus 138.75 meters per second, times half an hour is 1800 seconds, and that gives us an x component of the displacement value of minus 249,750 meters, and I should say a y component is the y component of velocity times time, and that is going to yield a value of 432,576 meters. Now, we're going to do two things here. We can express then the displacement vector as the x and y components, but there's one other thing we should do here, which is watch our significant figures. So at the beginning of the problem, if you remember, the magnitude of the velocity of the airplane was given as 999 kilometers per second, which is 3 significant figures. So if we have 3 significant figures for the y component of velocity, or for the x component of the displacement vector, we have minus 250 kilometers, converting it also back to kilometers. And if we convert the y component to have 3 significant figures, not convert, but if we express it with 3 significant figures, we have 433 kilometers. Okay, so that's our answer. We were asked to express the displacement of the airplane after half an hour in component form, which we have done. But are we right? We reign by surrender.
We reign by surrendering to Jesus and praying for our daily bread, which includes success
in our schoolwork.
God will answer and lighten our yoke and the impact of the thorns and thistles in our labor.
The last step of our problem-solving format, the A, stands for assess, which could be to double check, to do a kind of a reality check based on experience or knowledge you have, or to compute the answer using an alternate method to see if your answer was correct. So what we can do in this case is we can compute the magnitude of the displacement vector and in kilometers, knowing that the angle is 30 degrees west of north or 120 degrees. So the magnitude should be what? At the beginning of the problem, 999 kilometers per hour is pretty close to 1,000 kilometers per hour. Half an hour, you travel 500 kilometers. Okay? So that's what we have in mind. So it should be close to 500 kilometers. That's our gut check. So we have component form, which we're now going to convert back into the magnitude of the displacement vector using the Pythagorean theorem. And so that's going to be the x component squared plus the y component squared, and we take the square root, which is going to be negative 250 kilometers squared plus 433 kilometers squared. Take the square root of that, and your handy dandy calculator will hopefully tell you that that is equal to 499.99 kilometers. That's good. That's about what we thought it should be. Now, to make an independent calculation of theta, or the angle, we can take the inverse tangent of the components that we computed. So the vertical component is in the numerator, 433 kilometers. Horizontal component in the denominator with the sign, negative 250 kilometers. And we figure out what that is. Now, inverse tangent can be tricky depending on how your calculator is set up. You might get an answer in quadrant 1, 2, 3, 4, not all for this problem, but in a given problem. And so here, if you put it in your calculator, you're likely to get an answer of minus 60 degrees, but we know that we can add 180 degrees to that, and that indeed gives us the 120 degrees. So we are good on the magnitude of the displacement, and we are confident in that our components are corresponding to the angle that was given at the beginning of the problem. See you next time on Physics Like a Boss.
Written in the Word, in the good, good Word is a message from our God, gonna tell you all about how to get to the kingdom, the good life. Written in the Word, in the good, good Word is a message from our God, gonna tell you all about how to get to the kingdom, the good life.